This is Amitech Microwave Integrated Circuit Analyzer MIC-10. It consists of a receiver which works from a frequency of 5 MHz to 2 GHz. It also has a microwave source which works from a frequency of 5 MHz to 2 GHz. The source and the receivers are PLL synthesized. The source has a frequency of 87 to 898 MHz available at the SMA connector in that block. The frequencies from 899 to 2000 MHz are available at the output SMA connector when the up converter mode is enabled, being displayed by a glowing LED, while a frequency from 899 to 2000 MHz has to be outputted. The RF output connector has to be connected using a SMA cable to the up converter input. It also can generate frequencies from 5 MHz to 86 MHz using the down converter option available here. You need to convert the RF output using a SMA cable, and the lower frequencies are available at the SMA connector over here. The receiver also has got a similar operation. Frequencies from 48 to 860 MHz are received at the SMA connector in the RF input block. Frequencies from 861 to 2000 MHz are received at the SMA connector in the down converter block. A cable has to be connected from the down converter output to the RF input block. The corresponding LED will be glowing depending upon the display in the LCD when the corresponding block is being selected. Frequencies from 5 MHz to 47 MHz can be received at the up converter SMA input here. The corresponding LED will light up when the LCD will display the frequency. The operation of the instruments are similar. We need to operate the instruments using the 5 keys provided. As you can see, the microwave source right now displays a frequency equal to 1500.00 MHz. It also has a asterisk at the end. This asterisk is a PLL lock indicator. This has to be switched on permanently. In case it is not blinking, that means the PLL is not locked. That's the rarest of rare cases. There is a 001, that is the memory location. M stands for manual mode and S stands for 100 MHz, which is the step size. When we press up key, the frequency will increment in the desired step sizes. When we press down key, the frequency will decrement in the desired step sizes. We can adjust the controls by pressing the menu key. We press the menu key once and the location LED starts blinking. We can memorize the instrument to store different frequencies at different memory locations for quicker recall. We can select the option of manual and auto mode for the sources. Normal operation has to be done in the manual mode. We can also change the step sizes from 100 MHz to 50 kHz to 100 kHz to 250 kHz to 0.5 MHz, 1 MHz, 10 MHz, and so on. We right now selected 100 MHz as our step size. Pressing enter will blink the LED and store the corresponding menu options in the instrument. Now we come to the other parts of the microwave source. It has got a switch which says the modulation right now is in the CW mode. For normal operation, the instrument has to be kept in the CW mode of operation. In case a modulation is enabled, which can be done by flicking the switch in the upward direction, that will frequency modulate the source. Whenever we need to take the power measurements from the receiver, the CW mode has to be enabled always. In that condition, the instrument will output a power level of 0 dBm or 1 milliwatt at all its frequencies at the output connectors. We can frequency modulate the carrier by using an internal mic when the switch is selected to mic, or internal 1 kHz sine wave source. When the switch is in the 1 kHz position, we can adjust the deviation by using a control pot provided over there. We can also externally modulate the microwave source with the BNC connector here by an external signal from 20 Hz to 20 kHz. This will frequency modulate the signal. The source also has a trigger output which outputs a trigger of 10 millisecond TTL compatible for synchronization of the receivers in the auto mode. Now the operation of the receiver is also similar. We press the menu key and the location starts blinking. We press the menu key again and the instrument can be kept from the manual to the auto modes. We can change the step sizes as we've already shown you. We selected 100 MHz. Now the instrument is in the recall mode, so different memory locations will store different frequencies and level data which can be recalled later on. There is a control for serial mode equal to yes. When we press enter, the instrument starts to upload the different frequencies and level data stored at its 1000 locations to the serial port. The serial port has a RS-232 connector. This connector can be connected to the PC using the software, and the 1000 frequencies and 1000 level data stored at the memory locations can be outputted to the personal computer for visualization and interpretation of the data. We can interrupt the uploading. The instrument has come back on. We start running the instrument again. We can also change the measurement units. Right now the measurement unit is dB microvolts, which is displaying 167 dB microvolts. We can change the dB to dBm. Right now -40 dBm is the received signal strength at a frequency of 1500 MHz. We are generating a signal of about 0 dBm at the output connector of the source. We're using two 20 dB attenuators, which is why the signal is being read as -40 dBm. We can choose the units from dB microvolt to dBm as the case may be. We can also change the different dB relative modes. These are the normal controls we have to use. The instrument also has got a demodulator output. The demodulated signal is available at the BNC for viewing into the oscilloscope. It also has a received signal strength indicator, which is a DC level in proportion to the received RF signal. This DC level is from 0 to 2-3 volts, and which can be monitored on the CRO for level trending in the CRO. The instrument has also got a IF output. A 38.75 megahertz of IF down converted signal is available for monitoring into a spectrum analyzer for interpretation of the receiver operation. The receiver has got trigger inputs for transmitter and stepper motors. In case an automated display for the measurements is required, a stepper motor could be used. In case an automated frequency analysis is required, a trigger from the stepper can be used. We also have got a volume control which gives you the demodulated audio level into the speaker.